Now let's see LCM, least common multiple. So the name itself says that we have to find out all the multiples, but in finding out all the multiples is very difficult, and then we have to find out the common multiples and then the least one. See, unlike factors, finding out the multiples is somewhat difficult. Okay, so what I mean to say is, if you take 2, right, what are all the multiples of 2? So 2 is a multiple of 2, 4 is a multiple of 2, 6 is a multiple of 2, 8 is a multiple of 2, 10 is a multiple of 2, so like this. So you cannot find out all the multiples, right? Unlike that, finding out the factors, finding out the multiples can't be done. And this says that if you have 2 or more numbers, you have to find out all the multiples and then find the common multiples and then find the least one among them. So it is a bit difficult to enumerate them like this and then finding that out. In case of factors, you could have done it, and if we had put some effort. But here it is very difficult. So there are various methods of finding it. Let's see them. So LCM of 2 or more given numbers is the smallest number which is divisible by all the given numbers. Okay, see this. Smallest number means least. That is why we are calling it as the least. And then which is divisible by all the given numbers. That is why it is called as a multiple. Okay, common multiple. So that is why it is called least common multiple. And one more property that holds is, whenever you take 2 numbers and if you find out LCM and GCD, now if you multiply those 2 numbers, that product will be equal to product of their the LCM and GCD. We shall see this with an example later. Now let's try to find out LCM of 2 numbers. Let's take these 2 numbers which we have taken earlier, 8 and 14. If I take 8 and 14, what is their LCM, least common multiple? Okay, now see this. First one is prime factorization method, the same way which we have done earlier, but then final answer will be different. So because, see this, express each one of the given numbers as the product of prime factors, same as the previous method. You have to write both the numbers as if it is a product of prime factors, and then earlier what we had taken, the least index we have taken, right? But here see this, the product of the greatest power or index of the common primes is going to be the LCM. So there we had taken the least, and here we are going to take the highest. So what I mean to say is, we can write 8 as product of prime numbers, 8 is equal to 2 cube, and we can write 14 also as product of 2 prime numbers, right? Now you take the greater. So see this, the product of the greatest power index of the common prime gives the LCM. So you can add 7 power 0 so that all the numbers will be there, right? Now what is the greatest here among 2? It is 2 power 3. And what is the greater here? 7 power 1, right? So if you don't include 7 here, if you say that it is not 7 power 0, if you don't include it, you will not see it as a common, right? So here the common is given, right? Now if you don't include 7, you don't see that it is common in both of them, and you might leave it out. That is why it is better if it is present in some number, you write all the numbers with zeros there. Okay, since 7 is missing here, you have to write it as 7 power 0. Now 2 is common and 7 is common. Among these two, take the greatest and multiply them, right? So what is it? 2 power 3 into LCM is 2 power 3 into 7 power 1, which is going to be 56. Okay, 8 into 7, 56. Now next one is the division method. So we can use the division method to find out the LCM. So how to find out division method is, see, this prime factorization method can be applied even when the numbers are more than 2. Okay, so which means you can find out, you can take all the numbers and write them as prime factors, and then take the common primes and take the highest one and multiply it. That can be done here. And here in division method also, we can find the LCM of more than 2 numbers directly. In this case, let's examine with 2 numbers. Later we shall see more than 2 numbers also. So if we take 8 and 14, now how does the division method work is, so you take 2, divide. See, why am I taking 2 is, 2 is a factor of both of them. That is why I am taking it, right? You take 2 and divide both of them. Now what are the quotients? You write here, not the remainder, you have to write the quotient. So 2 4s 18 and then 2 7s. Now you keep taking the common factors and dividing them and keep going like this until you can't find any common factor other than 1, which means if these two numbers, if you take these two numbers 4 and 7, if you try to divide them with a common number, you will not be able to find anything other than 1. There you are going to leave it. And in fact, if two numbers are having only one common factor, which is 1, then they are called as co-primes. So you keep going like this until you go to a phase where no two numbers will have any common factor other than the common divisor other than 1. Got it? With practice you will be able to understand it, where to stop it. I will show you, but anyway you are going to stop it here because you can't divide these two numbers further. Now if you see this, it is 2 into 2 power 2 into 7, again the same thing, right? So it is 2 power 3 into 7, which is 8 into 7. Either you go like this or you go like this, same. So the answer is 56. Now if you observe it, earlier we have seen that the GCD of these two numbers 8 and 14, we got it as 2, right? Now LCM we got it as 56. So what this point is saying is, if you take product of two numbers, that will be equal to product of their LCM and HCF. So which means if you take 8 into 4, this will be equal to their LCM is 56 and GCD is 2. HCF or GCD is 2. Now these two will be equal, you can check it. Okay. So this is, and one more thing, this point is applicable only for two numbers. If you have more than two numbers, you can't apply it. So if we have found out LCM of three numbers and GCD of three numbers, you cannot say that product of three numbers equal to LCM into GCD of those three numbers. We can't do that. Only for two numbers it is applicable. Okay, fine. We shall see some more examples. With that, finding out all this will be easy. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.